Hello everyone. Today we gonna talk about the chapter 10.5. This chapter about absolutely convergence and root and ratio test. So when some of the terms of the series are positive and negative, the series may or may not converge. For example, we can write 5 minus 5 over 4 plus 5 over 16 minus 5 over 64 and so on. The series are positive and the negative terms. So definition of the absolutely converges is a series AN absolutely converges if the corresponding series of absolute values AN model converges. So by the theorem we have series of n model of AN if it is will converges. So series of AN will be also converges. So this what we have. So let's look to tests. First is the ratio test. So let's take series AN for AN more than 0 for each n more than sum n 0. So we can consider the limit n to infinity module of an plus 1 divide to an. So let's suppose that it will be equal for some p, and here we have conditions. So in first, if p will be less than 1, so it will be this limit, it will be absolutely converges. If p more than 1, or it will be infinity, so this will be diverges. If p will be equal to 1, so the test will be inconclusive. We don't know actually what it will be. So let's take some example. Series n for n equal to 1. Let's take n cube, divide to 5n, and let's take it by an. So if we take this an for this formula, we have that limit limit of n to infinity, we have here n plus 1 n plus 1, so it will be n plus 1 in square divide to 5 power of n plus 1, and this it will be equal to this, so we need to divide by some an it will be here, so we can write 5 power n and cube here, so this will be equal to 5, and we have this limit. This limit are here 5 will be 1 divided by 5 here, and limit of these two will be equal to 1. It's very simple. So here we have limit 1 over 5. So with our p, here we have p equal to 1 divided by 5, and 1 divided by 5 are less than 1. So by this condition, we can say that this series will be converges. So here let's talk about root test. Root test. So here we take the series an for an more than 0 for each n, more for some n 0. So we have this, we can say, we can consider the limit n for infinity, it's root in power of n an. It also be some p. So here we have also three conditions. For p less than 1, it will be conditions converges. For p more than 1 or equal to infinity, so we have here diverges. Or p is equal to 1, it will be inconclusive. So let's take some examples. Let's take series n square plus 1 divide to 2n square plus 7, and it is all will be in power of n. It's equal to an. So here it's obvious that this test should be used when we have some power degree like this n. When extracted from the root, this degree will be disappear. So if we write this series in this formula, we will be have, and for infinity, that's n square plus 1 and 2n square plus 7. This n will be disappear for this power of root. So its limit also very simple. It will be 1 divided by 2, and it is our p. So we have that p equal to 1 divided by 2, and this less than 1. So we have convergence series. So that is all. Thank you for your attention.